This is video 2 of quadratic surfaces. In the last video we talked about what a quadratic surface is and how we use cross sections to graph. We're going to do one more example in this video, and that is to graph the equation 4x squared plus 9z squared equals 9y squared in R3. So just like before, we want to figure out what the cross sections or slices look like. So when x is a constant, when y is a constant, and when z is a constant. And then we put those together to figure out the three-dimensional graph. So when x is a constant, if x equals 0, then we get 9z squared equals 9y squared. And we can figure out if that's the case, then z must equal plus or minus y. So we are going to get some lines through the origin parallel to the YZ plane. And so we have our YZ coordinate plane and these lines making 45 degrees with the y-axis and crossing at the origin. Now what happens if x is equal to plus or minus 1? So remember, we're just getting an idea of the cross sections, so you can pick a value for your x and just figure out what the cross section looks like for that value, just to get an idea. So if that's the case, if x is plus or minus 1, then we get 4 plus 9z squared equals 9y squared. And if we solve for the constant, then we get 4 equals 9y squared minus 9z squared. Now in the last video we talked about recognizing the equation of a hyperbola, and this is a hyperbola because we have a constant equals a squared term minus another squared term, and it will open around the axis of the positive term. So this is going to open around the y-axis, so it will go left and right. So that's parallel to the YZ plane. We get lines crossing at the origin and then hyperbolas as we move away from the origin. When y is constant, if y equals 0, then we have 0, 0, 0. So we know that we're going to have a point at the origin, which we already knew from those two lines crossing at the origin. If y equals plus or minus 1, then we get the equation 4x squared plus 9z squared equals 9. Now we know this is a equation of an ellipse. So this is an ellipse parallel to the xz plane. And it's going to be a little longer on the x-axis, because we're going to have a larger number in the denominator when we get it into standard form, or equal to 1. So it's kind of stretched out more in the x direction. And now we want to move on to when z is constant. So if z equals 0, then we get 4x squared equals 9y squared. So y equals plus or minus 2/3 x. We just solve for y. And so that's going to be two lines intersecting at the origin in the xy plane with a slope of 2/3 and negative 2/3. If z is plus or minus 1, then we get 4x squared plus 9 equals 9y squared. And if we solve for the constant, then we get 9 equals 9y squared minus 4x squared. Now remember, this is the shape of a hyperbola because we have constant equals squared term minus squared term. And we know it opens around the y-axis because the y squared term has the positive coefficient. So there's our hyperbola opening around the y-axis, so going up and down. Now we need to put all of this together. So we have our lines crossing at the origin. So I'm going to draw an X. And then we have those ellipses parallel to the xz plane and kind of stretched out in the x direction a little more than the z direction. And those hyperbolas around the y-axis in both cases. So what we end up with is an elliptical cone. In this case, the cone is kind of opening around the y-axis because we got the ellipses when y is a constant. And so we had the lines crossing through the origin, and we had the ellipses, and so it ended up making this double cone shape to the left and the right along the y-axis. Now, we only have covered 3 of the types of graphs that you might see in this quadratic surfaces section. But remember, in the guided notes or in your book is that chart of the 6 basic types of graphs, along with their names and the form of their equations. I recommend you look at that and review it so that you're familiar with the different names of graphs that you might see on your homework and test.